Okay. So thank you for coming. So today we are going to do, it's actually a knowledge sharing under our data science research lab. So you can actually go to our website, it's bit.ly/DSR lab seminar. Okay, so very easy to remember, bit.ly/data science research lab seminar. So if you go to the website, you can see we have a website where we actually archive all the talks that we have. Okay. For example, last presentation was Zach. Today, my talk is about Python and Numpy. So all the code for today you see here will be also available in GitHub. You can actually click on it and you can actually download the file. Okay. So you can actually go back and try. So okay. So to do Python and Numpy in 1 hour, I think it's quite difficult. Okay. So I just give you a brief introduction what Python, and then okay, I give you a brief introduction to Python, roughly the core concept, because you already know programming, so it's the core is about the same, just a bit the way how Python works. Then we learn about Numpy. Numpy is one of the tools that's widely used for data processing. Okay. Okay. So today we are I'm going to give you all the code ready in Jupyter Notebook. So Jupyter Notebook was used to known as IPython Notebook. Okay. So it's like an editor where you come together, you can actually run the code and you can actually put in Markdown. Okay. And you also can run other code, HTML, LaTeX, even now can run R code also. Okay. So you can see now I have my code here. This is like a normal Markdown file, and then you can see the code. Okay. So if you want to have a brief overview of Jupyter, this notebook, so basically you have a toolbar, you have a button here, then you can select the cell, to the cell, whether you want to be a markdown cell or code or whatever. And then you can see now I'm running on Python 3. As you know that Python has two flavors. One is Python 2 point something, another one is Python 3 point something. I see that there's no point learning the old version, Python 3 can do everything in Python 3. Okay. There is a minor difference, especially the free whatever use more with that. And then you can see there's a circle here. The circle here, when you see it's dark color, means it's processing. Okay. So sometimes it's processing, then you can see it's dark. Now it's not processing, it's white. Okay. So let's get an overview of Python. So Python is a very simple language. It's very straightforward. A lot of people are using Python as a first language to learn for programming. Okay. So actually Python is something we call wrapper language. It says read, evaluate, program and run it. Okay. So Python encourages programmers to program without any prepared code. It's very simple. Especially the free directive driver, you just bring up a line and it puts a new line, okay, and like C. So a lot of people compare Python like R, it's about the same. Okay, but of course the way it works a bit different. Okay. So you can see now I've written simple code here. So Python can run just like R with like a normal calculator. So you can see here 3 plus 5. So how you can run this code? You can just go to the cell and just press Control Enter. Okay. So you Control Enter, you get the result. Okay. So you can get the result. So you can edit the code, you can Control Enter, you can see the result. Okay. So you can see here I either can do 4 multiplied by 5 or 4 asterisk means 4 power 2. Okay. So I go down to the cell, I Control Enter, so I get the result. Okay, 4 power 2 will be 16. Okay, I cannot get the result 4 power 5 because 4 multiplied by 5 not shown because 4 power 2 override the 4 multiplied by 5. Okay. So like I said, Python comes in two versions. So there's two major versions. One is Python 2 point something, another one is Python 3 point something. So it's a bit different. Okay, so this tutorial uses Python 3. Okay, so Python 3 is more semantically correct and support a lot of newer versions. So one main difference between Python 2 and Python 3 is the print statement. So the print statement last time, okay, it's not a function for Python 2. Okay, whereas Python 3, the print statement is a function. Okay, and then therefore because the function, when you invoke the print statement, now you have to have a bracket to execute. Okay, So if you copy a code which is pointing to point something, normally you get error because of the pre. So you just put a bracket there, close it with a bracket. Okay, so for example here, I can assign a value to a variable x equal to 10, y equal to 50. So I can print x plus y, which is 50 plus 10. Okay, so I control enter, I can get the result. Okay, so you get the result 60. Okay, so this is how you from now it's kind of similar like R. Okay, so there are a few data types in Python. Okay, there are a few data types in Python. The first thing is called list. Okay, so now if there are those people that learn R, you get confused a bit. Okay, in R there's a list. In Python also has a list. Okay, so Python list is the most data structure in Python. Is basic data structure. So to create a list, we use a square bracket. Okay, we use a square bracket. So for example, S is a list here. It contains elements 1, 2, 3, 4, 5, 6. Okay, so then we can say we want to determine the length. Okay, we want to determine the length of x. Okay, so here the length of x is 6. So if you print the length of x, you get 6. Okay, so you control enter, you get 6. Okay, and then in Python, okay, we have a term we call slicing. Slicing means you select whichever element that you want. Okay, or in R we call it subsetting. Okay, so a list can be indexed or subscript. Okay, from the first element. Okay, remember Python, unlike R, you start index with 0. Okay, start index with 0. Okay, so for example, we can start here. Okay, so for example, we can start here x0. Okay, so my x is 1, 2, 3, 4, 5. If I put there x0, okay, if I put there x0, you show me that x0 is 1. That means the first element, the first index, x is 1. Okay, then I can put there, I can use the symbol semicolon. Okay, I can use the symbol semicolon. Semicolon means from the first index, which is index 0, all the way to the index this number, and don't take the number. So that means, let's say I have a square bracket semicolon 3. This one I will take index 0, 1, 2. Okay, I will take index 0, 1, 2. So when I control enter, you show me 1, 2, 3. Okay, because my element is 1, 2, 3, 4, 5, 6, 7. So index 0 is 1, index 1 is 2, index 2 is 3. Okay, so what does that mean here? If I put the 3 semicolons, what does that mean? That means start from index 3, start from index 3 all the way to the last index. Okay, start from index 3 all the way to the last index. So control enter, you take 4, 5, 6. Okay, you take 4, 5, 6. Okay, then what about this? Okay, negative 2. What does that mean? Negative 2 means you start the index from the back. So the last index will be negative 1, then following by negative 2. Okay, that means counting from the back. So you take the last two numbers. Okay, so when you control enter, okay, you get 5 and 6. Okay, so negative 1, if you put x negative 1, so let's try. If you put x negative 1, so you put x square bracket negative 1. So you see, if you put x square bracket negative 1, you get 6. Means what? Negative 1 means you start from the last index, so the last will be negative 1, then come in will be negative 2, negative 3, negative 4, negative 5. Okay? So if you put negative 2 square semicolon, means what? It means you're going to take the last two elements, starting from the last. Okay? Then from there, okay, you can actually add on. Okay? You can add on. You can use the function extend. Okay, in Python, when you want to call any function, okay, you can dot. Okay, for example, I say x dot. Okay, I will add another 2 elements, which is 7 and 2. Okay, x dot extend. So you will actually add 2 elements. 7 and 2. So when you control enter, now your x will be 1, 2, 3, 4, 5, 6. Now add 7 and 8 at the last. Okay. So extend also can be used another function which is append. Okay, which is append. So when you append 9, So what happened? So now your X is 1, 2, 3, 4, 5, 6, 7, 8. Now you have a 9 here. Okay. So you have 10 is the same. Okay. So let's say now, okay, let's say now I have a Z. Okay. Let's say now Z, I have a list now, Z. Okay. So let's say now I have a list Z. Z has the element 3, 2, 1. Okay. Z has the element 3, 2, 1. Now I would like to add X plus Z. Okay. What's my X now? My X is 1, 2, 3, 4, 5, 6, 7, 8, 9, and plus Z. So in Python, a plus means you concatenate. Okay. In Python, a plus means you concatenate. That means you add at the back, just like append or extend just now. Okay. So when you control enter, okay, you control enter now, you can see now X plus Z is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, and add the 3, 2, 1 at the back. Okay. Add the 3, 2, 1 at the back. Okay. So don't think the number now is actually number. You cannot do mathematical operation. If you want to do mathematical operation, you need to change to array. Okay, later we'll do in Numpy. Okay, now this is just an element. Okay, just element. Okay, so now your Z has a value of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 3, 2, 1. Okay, so you can sort them out. Okay, use the function sort. Okay, you just control enter, go down, control enter. You can sort. Okay. So, okay. So your Z is now was 3, 2, 1. Now you can sort to 1, 2, 3. Okay. You can sort to 1, 2, 3. You also can reverse the order of the sort. So you go become 3, 2, 1. So you can go control enter. You can reverse, become 3, 2, 1. Okay. Another thing is you can put a list inside the list. Okay. You can put a list inside the list. So let's say Y is 10, 11, 12. So Y is the list 10, 11, 12. So you can put a list of lists, variable name, and you can say the list of lists consists of the list of X and the list of Y. Y is of X, your S is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then plus Y. Okay? So you can actually do that. So you can actually add, okay, list of lists. So you control enter. Now you have a two list. Okay? 1, 2, 3, 4, 8, 7, 8, 9, over, and then another list 10, 11. Okay? So this is list. Okay? So list, okay, you can change the value of the object. Okay? Change the value of object. Okay, remember, okay, I want to show you this. Okay? Python is very important. Python has a concept, the pointer concept. Very important. Okay? So this one is not in your notes. Just want to show you this. Okay? This concept is very important. Please look. So let's say A. Okay, let's say A is assign a value string called foo. Okay? So A assign a value string foo. So I say B equal to A. Okay? If I say B equal to A, what is B? B is foo, isn't it? Okay? So I can actually go down here. Okay, I can add now print B. Okay? So sorry, no need to print B lah. So I know that B is equal to foo. Okay? Then I say A equal to A plus A. What's A plus A? Okay? Remember that now when we plus, we concatenate together. So become foo and foo. Okay? Become foo and foo. Okay? So when you print A now, okay, when you print A now, okay, you get foo and foo for A. And then when you print B, remember B just now was what? B equal to A, is it? So even though A has changed, B has not changed. Okay? So this concept is very important. That means what? No need. Which one? No, that's not a concatenate. No, that one is list of list. Here. No, I didn't put any comma. Yeah, F. Okay. The one that I put a comma because I want to two lists together. Okay, so this concept is very important. Means what? Okay, A is pointing to a value, memory for the word foo. Okay, B equal to A, that means B is also pointing to the memory, same as what A is pointing, which is foo. Okay, so how do you know the value for? You can put the print, the ID for A. So when you print the ID of A, you get what did you get? You get the number. This number, that means this number is the memory address to store the value of Hoong. Okay. The value of Hoong. So when I print the ID for B, let's say I print the ID for B. So print ID for B. Okay. You can see that ID for B is also the same value. Means what? B is pointing to the same memory address which is Hoong. And A the now was pointing to the same memory address as Hoong. But if you say A equal to A plus A, that means it becomes Hoong, then the memory address has changed. So A is pointing to a new memory address. Okay? So this concept is very important. Okay? So for example here, go back to here. Okay, go back to here. Okay, so this, let me go here, I add you something here. Okay, this is my X. My X is 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct? Okay, so, and then I say Z, okay, I say here, Z equal to A, Z equal to X. No, sorry, I want to say Y equal to X. So when I print my Y also 1, 2, 3, 4, 7, 9, correct? Okay, let's say now I say Y0 equal to 3. When I say Y0 equal to 3, what do I get? So it becomes 3, 2, 3, 4, 5, 6, 7, 9, isn't it? Okay, so if I print Y now, if I print my Y now, my Y will become 3, 2, 3, 4, 5, 6, 7, 9, isn't it? Okay, this is my Y, isn't it? Okay, now go print your X. When you print your X, what will happen? X also change. So very important. Even though like in R, we assign Y equal to X, that means now we have a Y memory, then we have an X memory. But if you put Y equal to X, if you change Y, you also change X. This concept is very important. If you do not know, you will overwrite everything. Okay? So this is X. We say Y equal to X. We thought that Y is going to be a copy of X. No. Y is still pointing to the same value as A is pointing. We change at Y, we say Y equal to 3. So when you print X now, X also changes. Okay? So this is what we call mutable object. Okay, in Python. It means you can change the value. Okay, you can overwrite the value. So you might be thinking, how do I not overwrite? If I make a new copy of Y, I don't want to overwrite the X, you have to specifically use the copy function. It means you make another copy. Okay. So how do you do that? You just put there Y equal to X copy. Okay, you put there X copy. When you print Y now, okay, see Y is, if I change Y equal to 5, Y equal to 5. When I put X, okay, X does not change. X still has 3. Okay. So whenever you deal with data, if you want to make another copy, you need to specifically mention you need to copy. If not, you will overwrite, okay, whichever value they're pointing by another variable. Okay. Okay. Another data type is called tuple. Tuple is immutable list. Immutable means you cannot change. Okay. Immutable means you cannot change. So how do you create a tuple? Okay, somebody in the video online, they say you can pronounce that as tuple or tuple. So I don't know. You can pronounce whichever you want. So I hear a lot of people say pronounce as tuple. So I just say tuple. So the difference between tuple and list is the square bracket and the normal bracket. So to create a list now was a square bracket. To create a tuple is normal bracket. Okay. So X now is 1, 2, 3. So if you check length of X is 3. Okay, now you have Y 4, 5, 6. If you check, if you slice Y, so Y2 is what? Y2 4, 5, 6. Y2 is 6. Remember, because Python start with index 0. Okay, so Y2 is 6. Okay, then you can create list of tuple. Okay, you can combine two tuple together. So you get 1, 2, 3, 4, 5, 6. Okay, so why do I say tuple is immutable? So if you say Y2 equal to 3, you want to change the Y2 equal to Let's say y2 equal to 3. You want to change, when you control enter, you get error. Okay, if you try to assign a new value to the tuple, you get error. You say tuple is does not support any assignment. Okay, it's a immutable object. You cannot change. Okay, so this is good. A lot of people argue, what's the point? I cannot change the value. What's the benefit? The benefit is because you can save the memory space. That's why Python can be so fast. If you think that you are not going to change the value, you just assign O as a tuple, then your memory space will be less. Okay. So that is tuple. Okay. So you can set, for example, you have a age, okay, income. You can create tuple age income. You can actually use the function to split. Okay. So you say I want to split by the comma. Okay. You want to split by the comma. So when you use the function split, that means once I find a comma, I split into two values. So I can print them as age and income. So if I print, I can get the value 32. So let's say I have a big data and all of them are split, I separate them by comma. Then I can use the split function. I can use the split function. Okay, so we have list, we have tuple, then we have dictionary. The dictionary is similar to any hash table. That means you assign a hash or index to a value. For example, I say captain. Okay, so to create dictionary, we use a curly bracket. Okay, we use a curly bracket. Okay, so we say captain is a active dictionary, and then we assign. Okay, we can assign that every index to a variable. Okay, I say enterprise to curve. Enterprise D to cut, this spaceline to disco, Voyager to gateway. So later, if I want to find the value for gateway, I just look for the Voyager, the index, the hash table. Okay. So you can actually control enter, you can get gateway. Okay. So let's say you have a table, data, you can actually store a dictionary. Okay. So you also can use a function get. Okay. So you say captain get. Okay, get the captain for the spaceship Enterprise. So when you control enter, you get curve. Okay. So let's say you try to find NX-01. There's no such spaceship in it. So when you control enter, you get none. Okay. So what can you do? You can use a for loop function. You can write a for loop function. Okay. Say for ship inside captain. Okay. For all the ships inside captain, we have all the captain in there. Print ship plus colon captain ship. Okay. Can you understand what all this? Ship means what? Okay, the ship name and then the captain. Captain ship means you want all the captain names. Okay. So in Python, white space is very important. Tab is very important. Okay, you can see normally when we write a for loop, we have our bracket there. So there's no bracket inside our for loop for Python. And then to compensate the bracket, we use tab. Okay, we use tab. Okay. So the tab is very important. So if you lose one tab or four spacing, you get error. Okay, so you run this, you get all your spaceship name and your captain name. And then this is you class in a string. When you class in a string, that means you concatenate them together. Okay, you concatenate them together. Okay. So we have function. Okay, we have function. So a function is a block argument that you can reuse. So this is similar to our C function. So to write a new function, we use a def. Then this is our function name, and this is our argument. Okay. Square IT is our function name, X is our argument, then semicolon, and then spacing. Okay. Spacing, then we will compensate our curly bracket. Then you say return X plus X multiplied by X. Okay. Then you can call this function square IT. Pass the value 2. So 2 go in here, so become 2 times 2. Okay. So you can actually control enter, you get the result 4. Okay. So you also can pass function around as a parameter. Okay. So you say I want to do something, another function is, and this function pass a function called square ID, and then pass the value 3. Okay. So the function will take another function. Okay, take it, and you can actually get the result. So the result will be 9, isn't it? So 3 plus 9, 2. Control enter, you get 9. Okay, so there's something you can actually use a function called lambda. So lambda is like you don't need to define a new function. You can just get an inline function. So lambda is a special name for inline function. That means instead of using def, create a new function name, you just use lambda. Okay. So lambda here, what we do? So lambda here means in the function, you're going to take the one argument x, and the argument will multiply it by itself 3 times. Okay. So lambda means you're going to create an inline function. No need to go and def what function is. So when you control enter, you get the result. Okay, where you create an inline function. The function will take one argument, which is x. So x now the value 3, and then 3 multiplied by 3 multiplied by 3. Okay, so that's lambda. Okay, then we have a boolean. Boolean. Inside Python, the boolean is true or false. True is capital T, and false is capital F. Okay, so you can say print whether x is equal to 3. Sorry, 1 equal to 3. So when you control enter, false. Okay, print true or false, true or false. Okay, you get true. Print whether 1 is equal to 3. 1 is 3. Okay, in Python you can use if, and, or, a and d, or or. Okay, you can start like that. Okay, so you say 1 is 3, so you use false. 1 is not 3. Then you can just use if, else if, and else. Okay, again, because there's no bracket in our else if, so if 1 equal to 3, 1 is 3. 3, how did that happen? Okay. If not, else if 1 more than 3, 3 back, else 3 all is well. So you can see whenever you have a new line inside the every argument, okay, should be a tab. Okay, so tab very important. So let's say I miss one spacing here. When I control enter, I get error. Okay, the tab is very important. So if you tab, okay, you control enter, you get the result. So 1 is not 3, so 1 is not more than 3, so you just print the last all is well with the word. Okay, so the tab is very important, and every time there's a colon. Remember that. Okay. So for we can write a for loop. So we already gone through a bit about for loop. So you can write a for loop, for example, for x in the range of 10. Okay. So what do you think x will be? X will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, every time x, when you have range, we start with 0. Okay. So if I say for x is in the range of 10, so print x, so I will get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So if I say for x in the range of 10, if x equal to 1, if x is 1, continue, then we just skip over. If x more than 5, then break. Okay. Then print x n equal to that one. Why I put that n equal to that spacing? That means I do not want it to start a new line. I want it to continue as a. You can see the previous one, it starts a new line. 0, 1, 2, 3. If I don't want to start a new line, I just put that n equal to that. So what do you think will be the result? So if x equal to 1, it continues. So 1 will not be printed. Okay, and then the value will not be bigger than 5. Okay, so we control enter, you get 0, 2, 3, 4, okay, 5. Okay, so because I put there n equal to b, if I delete this one, then I just will become 0, new line 2, new line 3, new line 4, new line 5. Okay. Okay, so for loop also we have while loop. Okay, so while loop is, you can say, while x is less than 10, then print x, then x plus equal to 1. This is like a normal while loop line. Okay, so start with x0, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you stop the loop. You control enter, you get like that. Okay, so exercise 1. Given the list of numbers, write a function to print the following result. 1 is odd, 2 is even, 3 is odd. Two minutes exercise. Okay, so quite simple, and then just to get the graph of writing the for loop and also the tab. So we can write for number in list of numbers, okay, string number and so if number is order 2 is equal to 0, we open. The next one, just use the continue lah. If you see modulus 2 is not equal to 0, just continue. Then the rest is string. Okay. Now this one later you upload the result Don't worry. No exam here. Okay. Okay. Next one. This one is very very interesting. So if you go and Google, how do I pronounce Numpy? You can see tons of results. Then there's a hot discussion in Reddit how to pronounce Numpy, because a lot of people pronounce as Numpy and Numpy. Okay. But the most of people they say unless if I pronounce Python not Python, then I'll pronounce as Numpy. Okay. So up to you lah. Okay. But a lot of people say it's supposed to pronounce as Numpy. Okay. It's because you cannot pronounce as Python, not Numpy. Okay. So that is right. So today I'm going to teach you one of the first one. The package normally people use is called Numpy. Okay. So Numpy is an open source module for Python. Okay. It's very common for mathematical and numerical operations, and it's very fast. Okay. Because the people have done a study, they show the code. If you just do everything in Python without using Numpy, it's about slower, 3 times slower. Okay. So Numpy is very fast. It's very mature. A lot of people are using it. So Numpy is actually part of the package for manipulating large arrays and instances of data. Numpy is under the library under SciPy. Okay, scientific calculation. Okay. A lot of people say because of Numpy and SciPy plus the matplotlib to plot the graph, it actually as good as MATLAB. Okay, and it's free. Okay. So if you are going to do big data, okay, if you want to do big data, you must know Numpy, SciPy, matplotlib to plot the result, and there are time on top of Panda, you are good enough to use Python to do your big data analysis. Okay, of course, the next one is to use scikit-learn to do machine learning. Okay. Okay, so Numpy development committee maintain a very extensive online is under numpy.org. Okay, so to run Numpy, we have to import library. Okay, so we can actually import Numpy. Okay. So normally you can import Numpy, or if you look at many code out there, they put import Numpy as np. Okay, so in the future you want to use the np library, just put np.whatever np.1. If not, you have to type numpy dot. Okay, then it will be very long. Okay, so when you import Numpy as np, that means whatever function inside Numpy you are called. If you think that you want to conserve memory, you don't want to import all, you can selectively import whichever that you want. You can put like this. For example, from Numpy dot random import what library. For example, import random like that. Something like that. Random whatever. Whichever function name that you want. Then you only import that function. Okay. If you put import Numpy as np, that means you're going to import everything, all the objects. Okay. So you can control enter. Make sure you have already imported Numpy as np. So why Numpy is very important? Numpy is very important because you can now work with array of objects. Okay, that means you can work with array of objects, basically matrices. Okay, so you can work with all numerical type and float integer. You can do large calculation of numeric data, which is very fast, and you can actually create lists. Okay, you can actually create list of arrays. So to create this array, we use the np.array. Okay, np.array. So we say now we're going to create an array, okay, which is 1, 1, 2, 3, and we store this array in the A. So we can actually control enter. Okay, so when you print A, you can see now A we say is an array. Okay, so this is different from the list that we see in the Python. So now you have printed this as array. It means what? You have printed this as a one-dimension matrix. Okay? One-dimension matrix. Okay, so if you check type of A, okay, will tell you this is actually a Numpy ND array. ND means number n dimension array. Okay? Number of dimensions. That means you can create 2 dimensions, 3 dimensions, 4 dimensions. Okay, multiple dimensions. So imagine you are working like images, okay, or you're working with complex images, then you can actually create a multiple dimensional data. Okay, you can do this in Numpy. Okay, so Numpy also allow you to do slicing. Slicing just now means you select or subsetting. Okay, so for example here, A semicolon 2 means what? Remember just now what we do? Semicolon 2 means what? Choose everything starting from index 0 all the way to 2, not including 2. Okay, so means 0, 1. Okay, index 0 and index 1. Okay, so when you control enter, you get 1, 1. Okay, remember our array is 1, 1 just now. What's the array just now? Our array just now is 1, 1, 2, 3. So when you put semicolon 2, that means you are going to take index 0 and index 1. Okay, if you put 3, what's A3? A3 is 3, isn't it? Okay, A3 is 3. Okay, control enter, you get 3. So let's say now, if I put A0 equal to 5, A0 equal to 5, that means I will change the first index, 0, which is 1, become 5. So when I control enter, I get 5, 1, 2, 3. Okay? So array can be multi-dimensional. So unlike list, different axes can access during the comma. Okay? So you can create array like this. Okay? So I have a first, if I create array 1, 2, 3, bracket, comma, 4, 5, 6, that means I'm going to create two row by 3 columns. Okay, 2 row by 3. So then I define the data type as float. Okay, I can put them, if I don't put anything, it will be integer. If I put a float, means I define the data type to be float. So when I control enter, I get a 2 by 3, okay, 2 row by 3 array. Okay, 2 by 3 array. Okay, so 2 by 3 array. Okay, also you can do slicing. If I put 0, 0 means what? The first row, okay, the first column. So the first row, the first column is 1.0. Right? So if you control enter, go down, control enter, you get 1.0. How about 1, 1? 1, 1 means the second row, the second column. Okay? The second row, second column is 5.0, isn't it? Okay, so you get 5.0. Okay, so array slicing work with multi-dimension, same as usual. Apply all the slice. Okay, you can use the dimension. For example, if I put like this, A, comma, semicolon, this one. The second row, all the columns. Second row, all the columns. What's the second row, all the columns? You get 4, 5, 6. Alright? Okay, second row, all the columns, you get 4, 5, 6. Okay, quiz 1. Display the number 3 and 0 for array A. Type. Then I give you here to type the answer. Type the answer. Oh, I put the answer here already. Crap. That's not the answer. Yeah, the second one. No, not the answer. Okay, so you want to display 3 and 6. Okay, you can get this one lah. Everything from everything, all the row, first and second row, but only want the last column. There's many ways. One will answer you first. Okay, the next one, now you think. This is only 2 dimension. 3 dimension it will work. So I want everything, all the 2 rows, because 3 and 6, one is on the first row and second row and that. Then I want the last column. Okay, I want the last column. How about the next one? I want 1, 3, 4, 6. Okay, I mean I want 1, 3, 4, 6. 1, 3. What's the similarity here? 1 is column number 1 isn't it? And also row number 1. 4 is also column number 1 but row number 2. Anybody got the answer? Okay, you can actually do like this. Okay. 0, 0, 0, 2, 1, 0, 1, 2. You can put like that. So you can see get. Okay, 0, 0, 0, 2, 1, 0, 1, 2. You can write like that. There's many answers. This is one of the answers. There are somebody they eliminate purposely only the middle, the middle two columns. You can write like that also. You can use you can play around with the semicolon. How you want to play around with it. Okay, so here you can put like this: -1 colon, -2 colon. What does that mean? -1. The first one means I want the last row, which is row number 2. Okay. Then comma, -2 colon means what? I want the last 2 columns. I want the number 2 row and the last 2 columns. Okay. Okay. So what do you get? You get 5, 6. Okay. Which is row number 2 and the last column 3 and 4. Okay. So how do you determine the size of the dimension of the array? You can use the function called shape. Okay. You can use the function called shape. So you tell you your dimension for array is 2 by 3. 2 row, 3 columns. Okay. 2 row, 3 columns. You can use the D type. D type means data type. Okay. Our D type of A, okay, is float. Okay. Float 64 bits. Okay. Maybe your machine is 32 bit. There is 32 bit. Okay. So you can reshape. Okay. Still got 10 minutes now. Okay. I'll try to finish with them. Okay. You can actually use a range. You can create an array using range. You can create a range using range. Range means what? You're going to create number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, isn't it? Then after you create it, you can reshape them to 5 by 2. That means 5 row, 2 columns. Okay. So let's say I get array A, which is 0, 1, 2, 3, 4, 5, 6, 7, 9. Then I use the function reshape to 5, 2. Okay. So when I reshape, what happens? You will change my number 0, 1, 2, 3, 4, 5, 6, 7, 9 to 5 row by 2 columns. Okay. 5 row by 2 columns. Okay. So you can do that. Okay. Then you can concatenate. Concatenate. Okay. This is similar to our R. We call it R bind and C bind. Okay. So you can concatenate. For example, you have A. A is 1, 2. B is 3, 4, 5, 6. C is 7, 8, 9. You can combine them A, B, C. So if you say you run this one, you can get what? Okay. You can combine them all into one. Okay. So other way to create array. Okay, you can use the range. Okay, NP A range. A range means what? Just now we have range, now we have A range. A range means you are using the array. Okay, we are going to create array. So 122. 122 means what? We're going to create 1 starting from the number 1 all the way to 20, step 2. Step up 2. Okay? So you can see, you can print. So you control enter, you can see 1, then plus 2, plus 2, plus 2 all the way to 90. And if you arrange 30, that means 1 is 29. Always remember when you do range, the last number you see is not included. Okay? The last number is not included. Okay? So you also can create an identity matrix. Okay, you call it identity matrix. Okay, remember identity matrix is not all the diagonal is 1. So you can actually control enter, you get all your identity matrix. So identity matrix only work with 6 by 6 or 5 by 5 matrix. if you remember your math. Then we can do array mathematics. Okay, we can add two arrays together. So let's say we have A 1 2 3, array B 4 5 6. If you add together, it means 1 plus 4, 2 plus 5, 3 plus 6. Okay, then you get 5 7 9. You also can minus, center. You also can plus. Okay. Beside that, what can you do? You also can do square root. Okay. Imagine just now if you don't use numpy. Imagine just now if you don't use numpy, let's say the number 14965, you don't use numpy, what do? You have to write a for loop there. Then go and square root one by one. Now you convert to a 2D array. Okay. Then you just square root it. NP dot square root A, you square all the elements. So 1, square root of 1, square root of 4, 9, 1. So you can control enter, you get 1, 2, 3, 4, 5. So beside that, you can do basic operation. Sum, okay, sum, then dot product. Okay, dot product means 5 multiplied by 6 multiplied by 7. Okay, then you can do sum all. Okay, so you can do A dot sum or A dot product. Or you can use the NP. The same one, NP dot sum, NP dot product, the same. Okay. So you want to do the one, you can just do A dot mean. You can do like that. Okay. A dot mean. A dot std. Okay, you can do like that. Okay, then you have something called argument mean. Argument mean means you return the index. Okay, you return the index. Okay, so let's say you want to find where is the value that is the highest minimum or maximum number. So return 0. Return 0 means what? Index 0. Index 0 is the one with minimum number. If argument max means return you what's the index of the location for the maximum number. Okay. The rest you can do. What can you do? You can do a selection based on argument. For example, let's say I have an A. Okay. I have an A. A is 6459. That means 2 by 2 matrix. Okay. Then you say display A more than 5. Okay. Display all the A more than 5. You get all the true false true false. But if you want to display the value, this is just like our R lah. You can just put in the square bracket. You get all the values. Okay. So the quiz you can do later if you want. Next one, we have we can do vector matrix multiplication. For example, let's say I have A matrix 1 2 3, B 0 1 1. If I want to do a dot product, okay. If I want to do a dot product, so what do I get? Okay, you have 1 multiplied by 0, 2 multiplied by 1, 3 multiplied by 1. Sorry, and then plus them together. So 1 multiplied by 0 plus 2 multiplied by 1 plus 3 multiplied by 1. So basically 2 plus 3, which is 5. Okay, dot product. Okay. So you also can, here, which is dot product A or B. So you can calculate the dot product A or B, dot product B of A, and then dot product AC, and dot product CU. Okay. So the way you multiply A multiplied by B and B multiplied by A is different, if you remember your matrix. Okay. Then we can do outer. Okay, you can do outer and inner cross product. Okay, so inner cross product is equivalent to your dot product lah. So if you do like that, get the result. So 1 multiplied by 2, 4 multiplied by 2. Okay, so you get your outer multiplication. Okay, you can do your inner dot product. Okay, inner basically is the sum with dot product sum. Then you can do your cross product. Okay, and then Numpy also comes with built-in routine. Can do linear algebra. Basically, for example, let's say I want to find the determinant. Okay, I want to find the determinant. Still remember what's the matrix determinant or not? Don't remember, never mind lah. Okay, run the function, get the result. So the determinant, you can just one line and find the determinant. Okay. Okay. Next one, we have random number generator. Random number generator. So random number generator, you can just feed the seed. You can set the seed. I put the seed as number generator. Okay. So the seed number is number generator. I say I want random 5. So random find means I got random find numbers. Okay. So I get a random find numbers. This is the five numbers. Okay. Then I can also random 2, 5. Okay. That means I go random 2 dimension array. So like this. 2 by 5. Okay. So this is 2 by 5. Yeah, I go random. I go generate 2 by 5 random number. Then I can generate a 10 number and I can reshape them to 2 by 5. That means I'm going to generate 10 random number. Then I'm going to reshape them to, reshape means I'm going to change them to 2 by 5 matrix array. So when I do, I get this. Okay. So if I really want to generate a random number from 0 to 1, I put random dot random. Okay. Because all these functions under the random package. So if you random number, if you don't put any number, you want to get a random number from 0 to 1. Okay. If I want to generate a number for a range, so let's say I want to generate a number for a range, okay, minimum 2, maximum 20, I can just put there 220, random integer. So you randomize number, which is minimum is 2, maximum is 20. Okay, so you can do Gaussian, okay, you can do normal distribution, all these things, okay. You can actually try it out. So if you want, you can actually try here. So the random, you can just use the random. Okay, so you can put like this. If I put a random normal, it's normal. If I put a normal for 1.5 to 4.0, I can get that. If I want a Poisson distribution, then it will become, it's under Poisson or zone. Okay, so random normal is normal distribution from mean is 1, then divided mean is 0, then divided 1. Random normal distribution minimum mean is 1.5, then divided 4. Ozone, then the lambda is 6 here. Okay, so this is a very crash course about Python and Numpy. If I got time, hopefully the next talk would be me. I got time, we'll do Panda. Then if I got time some more, we'll do Python. Okay. If you look at your this file here, I also included matplotlib. Okay, I also included matplotlib. So this is what you can do with matplotlib. This is what you can do in matplotlib. You can actually plot all the plot. You can go to your this one. Can you see this? The file explorer here. You can see your one got matplotlib here. One of the tabs. I open for you. You can see these are all the plot you can plot lah. Histogram, scatter plot, pi. You need the command. For time you do matplotlib also, but no time at this day. Too many things. Okay. So you can just go run all the commands. You can see the how it looks like. Okay, so this is a plot. Then you can actually plot. Control enter. You can see two. You can put two plots into one. You can save to a file. You can plot change the axis. Okay, you can put a grid. Control enter. Okay, you can change the line type, whatever. Okay, you can put a legend. You also can plot a XKCD style plot. Very interesting this one. Okay, you can see this is how XKCD. So you can plot like this. So if you want to plot something to make a fun of it, you can plot in there's a package XKCD package. Yes, plot XKCD. You can see the result of this. This is the day I realized I cannot make it very well. Interesting. Okay, then you can do pie chart. Pie chart. And you can do bar chart. You can do scatter plot. Of course, if you do not want to run all, you can try this one. Go to Canal. So where's the cell? Run all cell. Run all. So you run all for you and you get all the results. You can go cell and just run all. So you can see the run all the results will process. I don't need to go one by one going. If you got time, you can do this. Okay, so hopefully it will give you enough starting with the code already. You can go back and play around. The basic concept, I think you can get the whole of it. All the three files are available here. You can go back and download. But if you want to play with this, you have to install the Jupyter notebook, which is under. I installed the whole package called Anaconda. Okay, I installed the whole package called Anaconda. Anaconda come together with all the package, including scikit-learn machine learning. I don't need to install any package, whatever. It's all inside. If you just install Python, you go to download from python.org, then you have to install all the package one by one. Install Numpy, install Matplotlib, install SciPy, install Pandas, install scikit-learn all by itself. Okay, so you can, as you can see, a lot of people why they prefer Python. It's actually fast. Okay, it's quite fast. Okay, but you know, there are a lot of people still comparing whether to use R or Python. Okay, so I managed to complete everything by 4 o'clock.